Welcome to Good Genes, and on this channel we upload all the content that is related to engineering subjects that are going to be very helpful for you. So let's begin, and as you can see the title of this video, it is all about big data analytics. So we will be covering small concepts of big data analytics in every video that we release. Let's get started. So in the very first chapter of big data, that is Introduction to Big Data, we will cover the big data characteristics, types of big data, traditional versus big data business approaches, big data challenges, examples of big data in real life, and applications of big data. What is big data? Big data is a relative term if big data is referred by volume of transactions and transaction history, then hundreds of terabytes, that is 10 raised to 12 bytes, may be considered big data for a pharmaceutical company, and volume of transactions in petabytes, that is 10 raised to 15 bytes, may be considered small for a government agency. Well, very difficult to understand. Let's break down these points and learn slowly. Big data refers to the massive data sets that are collected from a variety of data sources for business needs to reveal new insights for optimized decision making. Big data refers to the collection and subsequent analysis for any significantly large collection of data that may contain hidden insights or intelligence that could be user data, sensor data, machine data, etc. Let's see what kind of user data. Suppose personal computers, PCs, can hold 500 GB of data. It would require 20 billion PCs to store zettabytes of data. Google stores its data in millions of servers around the world. Every day, around 10 million text messages are sent. Facebook has millions of active accounts and friends share content, photos and videos. What are these data? Where do they go? This exactly data is known as big data. Since they contain around petabytes, that is 10 raised to 15 bytes, they are nothing less than known as big data. And doing analysis on these data is big data analytics. These data are mostly related to human behavior and interactions, and this helps the information technology analyst to store and analyze data to extract useful information that drives the business. Why big data? Since I just mentioned increase of storage capacities, increase of processing power, availability of data. And every day we create 2.5 quintillion bytes of data. 90% of the data in the world today has been created in the last 2 years alone. This is the rise of data that's happening. Facebook generates 10 terabytes of daily. Twitter generates 7 terabytes of data daily. IBM claims 90% of today's stored data was generated in just the last 2 years. The sources of big data include users, applications, systems, sensors. Big data analytics, as shown in this figure, is the result of 3 major trends in computing, that is mobile computing, that using handheld devices such as smartphones, tablets, social networking such as Facebook and Pinterest, and cloud computing, by which one can rent or lease the hardware setup for storing and computing. So the 3 types, the 3 main keys that are used as big data: the social network, mobile, and cloud computing. Other major sources of big data includes power grid data, transport data, Search engine data. What is power grid data? The data that comes from power grids. It holds information on particular nodes such as usage information. Transport data. This includes possible capacity, vehicle model, availability and the distance covered by a vehicle. Search engine data. This is one of the biggest sources of big data. Search engines have vast databases where they get their data. Now we come to the 4 V's of data, that is volume, variety, veracity and velocity. Volume as a mathematical notation goes in length into breadth into depth. Since data in real time, we can interpret it as how long you need to collect the data, and so the interpretation of length, breadth and depth is as follows. The length is the time dimension. What are the different sources or from where the data has to be collected and how should the data be integrated? Discovery and integration form the breadth, and analysis and insights form the depth. This is all about the volume. The data that comes from a wide variety of sources is random and unstructured. The increasing volume of data outstrips traditional data store. Hence, data loading in warehouse will become slow. It is difficult to control the data flow because genuineness of the data, that is veracity, has to be verified before loading the data. So we have seen right now volume and veracity. Veracity is nothing but the genuineness of the data. The data has to be verified that is the real true data. Velocity is taken into account for time limited process, since it streams data from the real world into the organization to maximize the value of information. In all, big data have 4 major components, that is volume, velocity, variety and veracity. There is also one more V that is added lately to the big data, that is value. Types of big data. Traditionally, database terminology, data sets are rows of table corresponding to the transactions. They are also called the operational data. These are structured and have known data types such as numeric, floating point, character, string. Transactions and its history are extracted, transformed and loaded, that is the ETL process. The extraction, transformation and the loading process into the data warehouse. Using data mining algorithms, the hidden information or the pattern is derived and used for business predictions. XML data is semi-structured. Semi-structured data does not have fixed fields but contains tags to separate data elements. XML is extended markup language. RDF is a graph data. Apart from these, there is streaming data, which is an ordered sequence of instances that are scanned only once using limited computing and storage capabilities. Examples of data streams include phone conversations, ATM transactions, computer network traffic, web searches, and sensor data. So now let us see the difference between traditional versus big data approach. Traditional data management and analytics store structured data in data marts and data warehouses. Traditional data management too was able to handle huge volume of transactions, but up to an extent. For example, billion of credit card transactions worldwide could be handled, but not peta or zettabytes of data, and that too in variety of formats. Most important problem of the business organization is to understand the true customer experience. Business organizations have multiple customer inputs, including transactional systems, customer service, that is call centers, websites, online chat services, retail stores and partner services. Customer may use one or more of these systems. The alternative to this problem is the big data approach. Many IT tools are available for big data projects. The storage requirements of big data are taken care by the Hadoop cluster. Apache Spark is capable of streaming processing, that is advertisement data. When used, these tools can dramatically reduce the time to value in most cases from more than 2 years to less than 4 months. So this was the difference between traditional versus big data approach. We are landing down now to advantage of big data analytics. So the advantages of using Hadoop over traditional storage system such as RDBMS is scalability, because the nodes can be added to scale the system with little administration, with very less administration or probably no administration needed. Unlike traditional relational databases, no pre-processing is required before storing. You can just store the data directly in Hadoop. Any unstructured data such as text, images and videos can be stored. There is no limit to how much data needs to be stored and for how long. As we have seen the 5 ways, we then understand this sentence that there is no limit to how much data needs to be stored and for how long. Protection against hardware failure. In case of any node failure, it is redirected to the other nodes. Multiple copies of data are automatically stored. And now we cover the last topic, that is the applications of big data. Big data can be applied to real-time fraud detection, complex competitive analysis, call center optimization, customer sentiment analysis, intelligent traffic management, managing smart power grids, government, international development, manufacturing, media, that is Internet of Things and technology, private sector, science, sports, research activities and much more. According to me, I think big data is a subject that you might be having in your Sem 8, the very last semester of your engineering syllabus. We come to the end of the first chapter of Big Data Analytics. Make sure you like and subscribe to our channel. In case of any doubts, please feel free to ping me up on the email ID given below.